All right, let's jump right into today's explainer. We're going to unpack a specific, completely public project called Parallelist_training. Now, on the surface, it might look like just another quiet page on the internet. But if we dig a little deeper, it actually tells a highly compelling story about ambition, incredibly clean code, and massive infrastructure.
First up, let's look at what I like to call the underdog repository. So, that quietness I just mentioned, it is perfectly reflected in its stats. This project literally sits at absolute zero right now. We're talking 0 stars, 0 watchers, and 0 forks. It's a true hidden artifact. You know, in a developer community where popularity is almost always measured by who is watching or copying your code, this project flies completely under the radar with 0 published packages.
But hold on, because you have to contrast that absolute zero with this next number, 124 million. Because this completely unstarred, unnoticed project is actually built to handle a 124 million parameter AI transformer model. To put that into perspective, that's roughly the size of the original GPT-1. It is just a staggering juxtaposition, right? You have this project with practically 0 digital footprint aiming straight for a massively ambitious goal. So what exactly is happening inside this code?
Which brings us to Section 1, the Core Benchmark Challenge.
The project's own documentation lays out an incredibly dense claim. It states that it implements a 124 million parameter transformer completely from scratch, just to benchmark PyTorch DDP against deep speed. They aren't just downloading a pre-built model off the shelf here, they are doing the absolute heavy lifting from the ground up, literally just to run a test.
Think of this setup as a digital boxing ring built specifically for heavyweight distributed training frameworks. In one corner, you've got PyTorch DDP, and in the other corner, you have deep speeds 0.1 and 0.2. For some quick context, these are vital strategies used to split massive AI workloads across multiple GPUs. So this zero-star project is really a highly specialized laboratory designed to figure out which strategy is the absolute most efficient for memory and speed.
Moving right along to Section 2, Project Setup and Architecture.
When you break down the codebase, it's almost entirely driven by Python, 98.4% to be exact, with just a tiny 1.6% sliver dedicated to a Docker file. There is literally no bloat here. It is pure, hyper-focused Python code doing the heavy lifting for the transformer, alongside just enough Docker instruction to get the container up and running.
And get this, the history shows this entire benchmarking architecture was pushed in exactly 2 commits. 2. Think about that for a second. A complete, fully functional testing environment for distributed AI training dropped onto the platform basically all at once. It really speaks to a highly deliberate, calculated approach by the developer, and it honestly highlights how rapid prototyping has fundamentally changed modern AI development.
The file structure itself is like the perfectly organized anatomy of an AI project. It's so neatly separated. You have SRC for the core logic, configs for your parameters, scripts to actually run things, and outputs to catch the results. There's even an engineer's guide included, which shows a serious level of professionalism and a real intent to document the work, despite having literally 0 watchers.
And despite that highly complex 124 million parameter goal we talked about, the execution is elegantly reduced to just 2 precise steps, using Docker to ensure perfect reproducibility. Step 1, you build a training environment. Step 2, you run the Python script, actively passing in your specific strategy, like DDP for PyTorch. It's incredibly technical, yet it's so streamlined that you could spin up this massive benchmark on your own machine in a matter of minutes.
Let's zoom out a bit for Section 3, the GitHub Developer Ecosystem.
It is actually fascinating that a humble, 0-star benchmark test shares the exact same infrastructure as massive enterprise workflows. We're talking about things like app modernization, automated CI/CD pipelines, and advanced DevSecOps security integrations. Sitting quietly right in the middle of all that heavy-duty corporate infrastructure serving Fortune 500 companies is Manish Cody's little 2-commit experiment.
And the platform surrounds these code bases with some seriously cutting-edge AI add-ons. You have Copilot for writing better code, Spark for building intelligent apps, GitHub models to manage prompts, and the MCC registry to integrate external tools. It's an entire AI code creation suite hovering right above our hidden transformer project. It represents a massive leap in how fast code just like this could be expanded or iterated upon.
Plus, the ecosystem provides instant dev environments via code spaces, automation through actions, and enterprise-grade advanced security to stop leaks before they even start. The contrast here is just amazing. You have a solo developer running a raw two-step Docker benchmark, while the platform hosts it on an infrastructure that offers 24/7 premium support and secret protection designed for global banks.
To wrap things up today, I really want to leave you with this final thought regarding that incredible contrast between a solitary developer's code and the boundless potential of the platform it lives on. If one person can quietly set up an arena to test deep speed against PyTorch with just a handful of Python files, imagine what happens when an entire enterprise team turns the full weight of Copilot, code spaces, and advanced security onto a project like this. It really makes you look at every hidden, zero-star project out there with a little more curiosity, doesn't it? Keep exploring.